Assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
For this problem, you're being asked about a piston that has a block on top of it that's moving up and down, and trying to figure out at what point, at what amplitude, if the piston has a period of 1 second, will the block and the piston separate. So you're trying to find at what amplitude will the acceleration of the block be greater than the acceleration of gravity holding the block to the piston. We're going to use the equation acceleration equals omega squared times amplitude in order to solve this problem, and we're actually going to make that equal to gravity, because when the acceleration of the block and the gravity are equal, that is going to be the tipping point for when the block will start to separate from the piston. Now, since we don't know the acceleration of this, and the only information we have about this situation is the period, we're going to be swapping out our omega, changing that term. So we have omega equals 2 pi times your frequency. And we also know that frequency equals 1 divided by the period. So when we put those two together, we essentially get that our omega is 2 pi over our period. So we can substitute this in for our omega here. We know that gravity itself is 9.8 meters per second squared, so we can substitute that term in as well. And so we end up with this equation. 9.8 equals 2 pi over t squared times our amplitude. And so we can then solve for our xm, because we can take our t and replace that with our known value of 1.0, and we end up with xm equals 0.25 meters. And so that is the amplitude at which the block with this period will start to separate. For the next part of the problem, we're being asked what if the piston has an amplitude of 5 centimeters, which might as well just go ahead and switch that right into meters, so 0.05 meters. What's the maximum frequency for the block and the piston to remain in continuous contact? So we're basically going to use the same thought process as before, but this time we're going to be figuring out frequency instead. So we're going to use our omega squared times our amplitude equals our gravity. And again, we know gravity is 9.8 meters per second squared. And we're going to once again replace our omega term with the 2 pi f this time, so we can solve for frequency. So we'll have 2 pi f squared times our position times our amplitude equals 9.8, and we can substitute in our 0.05 meters for our amplitude, because that's when we're trying to find the frequency for that particular amplitude. And so we end up with an equation of frequency equals the square root of 9.8 divided by 0.05 all over 2 pi. And we get a solution of frequency equals 2.23 hertz.